Hello everyone, in this video we discuss on the topic fixed and floating point number representation. Also we will see some numericals. So let's get to learn. In this video we will cover the theoretical background, fixed point number representation, examples related to fixed point representation, float point number representation, examples related to float point representation, and the summary. Theoretical background. Digital computers use binary number system to represent all types of information inside the computers. There are two major approaches to store real numbers so that numbers with fractional component in modern computing. These are, first one is fixed point notation and second is floating point notation. In fixed point notation, there are a fixed number of digits after the decimal point, whereas the floating point number allows for a varying number of digits after the decimal point. Now we see the fixed point representation. This representation has fixed number of bits for integer part and for the fractional part. There are three parts of a fixed point number representation. First part is sign field, next is integer field, and the fractional field. This is represented by 32-bit representation. It is further divided into 1 bit for sign field, 15 bit for integer field, and 16 bit for fractional field. Now we see the example. Represent the number minus 43.625 in fixed point number representation. Assuming number is using 32-bit format which reserve 1 bit for sign, 15 bit for integer part and 16 bit for fractional part. Let's see in step 1, split the number and convert it into binary. In step 2, now put the binary digits in respective cells of representation. In step 3, place the zeros in all other remaining places. In step 4, place 1 in sign bit as the number is given is negative. Now we move to floating point representation. Most computer manufacturers use IEEE 754 format to represent floating point numbers, and IEEE 754 float 4 bytes or double 8 byte has three components. First is sign field, exponent field, and mantissa field. It is represented by single precision 32-bit and double precision 64-bit. Now we see one example. Convert the number 85.125 into IEEE 754 single precision. Now in step 1, the separation of number is done. The number is separated into whole portion and in decimal portion. In step 2, convert the decimal portion into its equivalent binary number. In the step 3, combine the two parts of the number that have been converted into binary. Step 4, convert the binary number into base 2 scientific notation. In step 5, get the exponent based on precision and turn the exponent into binary. Step 6, determine the mantissa and put in the cells. Here in step 7, determine the sign of the number and display in the binary format. Finally, in step 8, we compile the 3 parts into one final number. Here we have a note. We have to fill rest of the mantissa with zeros. So let us take short overview of these concepts. Fixed point, a representation of real data type for a number that has a fixed number of digits after the radix point. Floating point, a formulaic representation of real numbers as an approximation so as to support a trade-off between range and precision. Fixed point is used to represent the limited range of values, while the floating point is used to represent a wide range of values. Fixed point have a higher performance. Floating point is comparatively have a lower performance. Fixed point is less flexible, while the floating point is more flexible.